Hello, my name is Pratyosh Changmai and I am roll number 81 and I have got the question number 16. Simulate natural convection in a square cavity with top wall adiabatic and other vertical wall isothermal and a bottom wall is mentioned. Heat flux is equal to Q naught sine pi x by L with Q naught as a reference heat flux. We need to show the velocity vectors and temperature contours. And now I want to proceed with my solution. I open the workbench. With workbench, I will open the system fluid flow fluent. Here the fluid flow fluent model starts with geometry mass setup solution results. We are going to open the geometry first. I am opening it on the design modular. First of all, I will create a square of dimension 1 meter and 1 meter using the rectangle toolbox. Now I will modify the dimension with taking the Zenel settings. I will click on both the lines and give a reference height and a reference vertical position. Here I will type the dimensions 1 meter and again vertical dimension 1 meter, which makes the rectangle a perfect square of 1 meter square area with sides 1 meter each. Here is my square cavity, and now I will make this square cavity 2D by clicking on the concept tool, selecting surface from sketches and taking the selection filter edges. By clicking the selection filter edges, I will click and select all the edges 1, 2, 3, 4, and that's it. Now I will apply it. Yes, and I will click generate, hence the surface is generated, and I completed my geometry in the design modular. Now I will open mesh and do fine meshing. It is taking little time. It is taking little time. Yes, the mess is opening. Yes, this is the perfect view. First of all, I will name all the edges. Left wall, right wall, bottom wall, yes, the name selections are done. As you can see, left wall, right wall, bottom wall, top wall. Now I will start meshing with it. I will start the face meshing by selecting the face and applying it, and face meshing is done. And again I will do the edge meshings. Edge sizing. I will select all the edges. One, two, three, four. Four edges are selected. I will change the element size to number of divisions. I will put number of divisions 100. Yes. And I will do refinement. Yes. Now I'll update the mesh. Yes. Sorry. I will select the refinement on the face. Yes. Yes. Yes, the face is refined. And again I will do the edge refinement. Yes, the refinement is done. And I will do again the refinement of the edges. Two, three, four. Yes. Updating it. It is getting updated. Yes, our mess is ready. Now I will go to the Fluent setup. We'll select double precision 2D. Start. It's taking time. Okay, our solver is ready. We will first on the gravity and put on y-axis the value of the gravity minus 9.18. Okay, and to the model I will on the energy equation. Change is to viscous to laminar. Laminar, yes, yes, it is done. Now I will choose the material fluid here. We'll change it to Buznik equation. Buznik 1.22, change it to 0.003. Enhanced thermal conductivity is 0.042. Cp of the air is 1006.43 joules per kilogram Kelvin. We have created a change. Everything is okay. Now I will move to the boundary conditions. I will put the top wall adiabatic. Heat plug 0, wall thickness 0, heat generation 0. Apply, close, close. And left wall as the reference wall. With temperature 400 Kelvin is applied. Close. And taking the right wall temperature as 300 Kelvin. And now the interesting part is the bottom wall. And taking the heat flux 1000 1000 into sine pi into x divided by 1. Watt per meter square. Watt per meter square into sine into pi x divided by 1. Yes, it is the correct equation, and I am taking Q naught is equal to 1000 with all the units correct. It is applied. And I am taking initialization. Taking methods simple Initialization, hybrid initialization, and manually initialize the conditions. Hybrid initialization is done, and now I'm going to run the calculations with taking the number of iteration 500 and I'm starting calculation. It's taking time. I'm connecting my charger. Yes, charger is connected. Yes, my calculation is completed. You can see the scale residuals as obtained. Now we will go on to graphics, contours, temperature, static temperature, interior surface body, and here we obtain the temperature contour where the bottom wall is heated and a little bit heat sharp obtained from the left to the right, as you can see. Now I will show the velocity vectors. Hence the velocity vectors are obtained. Recirculation vectors. These are vectors, recirculating vectors. And hence my project is completed.